This is 3.2 polynomial functions of higher degrees. We just got done studying about quadratics, and once you understand the basic idea of quadratics, you can just take it from the next step is to do any type of polynomial that's third degree, fourth degree, fifth degree, any type of thing. So first of all, polynomial functions are continuous. So we did talk about piecewise functions and other type of functions that are not continuous. But notice one of the things for polynomials that we're going to be studying now are polynomials are continuous. So here's an example of yes, no, and no. So notice, and by the way, they're smooth. So this first example is it's a nice smooth curves and it's continuous. This second example, notice it is continuous, but it's not nice and smooth because once you get down to this point, now it's like a rigid or a sharp turn. So that's not a polynomial. And then here, this is a piecewise function, so it's not continuous. So once you pick up your pencil and then start again, then it's no longer continuous. So they may be functions, but we're specifically going to be talking about just polynomial functions. So remember, polynomials are continuous and they're smooth. All right, so let's talk about even degree functions. So even degree functions, so x squared, x to the fourth, x to the sixth, x to the eighth, and so forth, all have the same type of end behavior. And so if you look at this, so if the a, so like literally the first term, x to the 8th power, x to the 20th power, whatever it is, if it's a positive, the end behaviors will go up. Literally the end behavior of the polynomial will go up. The left side and the right side will go up. If it's negative, then they're both going down. Again, think of the x squared, just a parabola. So parabolas look like this. See, they're both going up. Well, x to the fourth would do the same. X to the sixth, x to the eighth. Again, it may do some, if you look down at this polynomial down here, 3x to the eighth, this first example, 3x to the eighth, see the polynomial may do some weird things in the middle. That's why I have, I don't have really it could actually do, some weird things in the middle. It could do something like that. Something like that. But whatever it does in the middle, I'm focusing on the end behavior. The end behavior, if it's an even degree, the end behavior will both go up if it's a positive. And then the same thing, if you guys know, if you had y equals negative x squared, the parabola is going to go down. Well, again, what if this is, x to the 6th power? Look at this example, x to the 6th. It could do some weird stuff in between, guys. It could do whatever this is in between, but the end behaviors, the left side and the far right side, will both be going down. And so that's what I want you to pay attention. If it's an even degree function, the end behavior. And also notice, this right here is something you need to always consider. This right here is something you need to consider. So as x goes towards infinity, so think of x as 1, then 2, then 3. When x is getting bigger, 4, and it goes towards infinity, well, what is the y value doing? Well, notice the y value is going up. It's going towards positive infinity. As x goes negative infinity, so as x goes towards negative infinity, the y value is going up. So it's going towards positive infinity. That's if the a is positive. So if the a is negative, just like this one, as x goes towards infinity, positive infinity, y goes towards negative infinity. So as it gets further and further this way, the graph gets further and further down. As x goes towards negative infinity, then y goes towards negative infinity. I do suggest some students literally try to memorize this, and they do that. I would just memorize the end behavior. Know the end behavior up here, and then as x goes this way, what the graph is going to be doing. As x goes this way, then what the graph is doing, if you know the end behavior. So let's look at odd degree functions. So odd degree functions, again, if a is positive and a is negative, it's going to look like this. So a positive, it's going to look like this. And again, you have an example right down here. So the A is positive, but it's a 5th degree. So the end behavior, again, it could do stuff in between here, it could do stuff in between, but you know, whatever it is, it could just be one loop or whatever it is, the odd degree, well, the end behavior is going to look the same. And as x goes towards infinity, y goes towards infinity. As x goes towards negative infinity, the y value is going toward negative infinity. Again, look at the graph, and then you should be able to answer those questions. Here, if a is negative, so notice you have a negative odd degree, the end behaviors are going to, again, it could do stuff in between. It could do stuff in between there, but you know, depending on how big this is, if this is x to the 17th power, then obviously there's going to be a lot more things in between, but the overall end behavior is still going to be the same. So as x goes towards infinity, y goes towards negative infinity. As x goes towards negative infinity, y goes towards positive infinity. And then you should be able to notice how the graph is going to go in a general format. All right, so if I gave you these functions, again, just look at it and then know the left hand and the right hand behaviors. So all you need to do is look at, notice that's an odd degree and it's negative. So notice if you go back and look at the charts, if you don't have it memorized yet, it's going to look like this and then this. The overall graph will look like that. Again, it may do stuff in between. That's not what I'm focused on. I want to know the left hand and the right hand behavior. So notice the left hand behavior, that's the left hand behavior. The left hand, so if you're doing left hand behavior, what will the left hand be doing? It's going up towards positive infinity. And the right hand behavior is going to be going down towards negative infinity. The next one, again, I have a positive x to the 4th power. Well, positive x to the 4th means they're both going up. And if they're both going up, that means the left hand and the right hand are both going up and then towards positive infinity. This is a positive x to the 5th, so the end behavior will look like this. So the left hand will be going down towards negative infinity, and the right hand will be going up towards positive infinity. So let's talk about this next thing. So you might want to pause the video. This is a very, very crucial page of information. So we're going to talk about finding the zeros of a polynomial of whatever degree. So, you know, to the 2nd degree, to the 3rd degree, to the 20th degree. It doesn't make a difference, to the nth degree. So we're talking about real zeros. So first thing is, at most there's n zeros. So if I had a 2nd degree, then at most there are two zeros. Again, think of a parabola. So a parabola could cross at 2 spots. It could. It doesn't mean it will, but it means it could. So at most there's 2. If it was x to the 3rd, so at most there's 3 zeros. If it was x to the 4th, at most there's 4 zeros. The next thing is, at most there's n minus 1 turning points. So again, think of the parabola. So the parabola, because it's x2, n minus 1 means there's only going to be 1 turn. And that is so notice it's turning, it just turns from down to up. It only turns 1 time. And x to the 3rd, again, 3 minus 1, so at most it's going to have 2 turns. At most it's going to have 2 turns. So you always take, whatever the degree is, you're going to basically take 1 and it's going to subtract 1, and that's at most it will have the turning points. So even something like an 8th degree, at most it's going to have 7 turns. Okay, so an 8th degree is going to look like this, the end behavior. So at most, it can have literally go down, then back up, then down, then back up. But at most, it's going to have 7 turns. Okay, at most. The next thing, if x equals a, and that is a 0, then x minus a is a factor. This is super, super crucial. So a lot of times you guys know to factor, right? And this is an example. You would factor quadratic, and you might get x minus 3, x plus 5. And then you set this equal to 0, and set this equal to 0, and then you solve. So x equals 3, x equals negative 5. Well, that's what this is saying. So if this is a 0, if I know that's a 0, then x minus that is a factor. If I know this is a 0, then x minus that, x minus a negative 5, which is x plus 5, then that is a factor. And it goes both ways, by the way. So if this is a factor, then I know that I can set that equal to 0 and solve it for a 0. So that's a very crucial step. The last thing is to find the x-intercept, just like what we have here. If you set it equal to 0, then 3, 0, and 5, 0 are the x-intercepts, or the zeros, negative 5. All right, so a lot of those you already know, but there are some crucial things that you need to pay attention to and make sure you know those facts. So if I notice this problem right here, notice I have this is a 4th degree. If I have to tell you this is a 4th degree polynomial with the leading coefficient of 3, so I'm going to ask you to find the polynomial. Like, we don't know what the polynomial is. Well, I do notice that a 0 is 5, so x equals 5. I also notice x equals 2. And I also notice x equals negative 2. Well, remember the fact that we just covered. If I know those are zeros, that means this is a factor. X minus 5 is a factor. This is x minus 2 is a factor. And then x plus 2 is a factor. So if I multiply those out, so literally what I'm going to do is multiply those out. Just literally FOIL them. So I FOILed the first two and got this step, and then after that I just used the distributive property and I simplified and got this. Now that's not the final answer, because notice the instructions find a 4th degree, and something I do want to point out. So notice the instructions said find a 4th degree, but I only got a 3rd degree. Well, one of the things that we're going to learn in the next frame here, but x minus 5, this one right here, let me highlight that, this one right here, is actually being repeated twice. And you're like, well, how do you know that? Well, we're going to get to that in a minute, but I know it's going to be repeated twice. So there's actually another x to the minus 5. And basically, if you can actually see it, why it's going to do that. But basically, you notice this one goes through 0. But this one doesn't go through, it comes down to 5, then it bounces back up. Well, because it bounces, I know that it's a repetition, okay? So I know that one happens twice. So we're going to say that in the next frame as well. But so what we need to still do is multiply all of this by x minus 5. Okay, so we're going to multiply all that by x minus 5, because again, I know it's a 4th degree. I multiplied all that out, and I'm going to get this. And notice, go back to the instructions, find a 4th degree polynomial, which I did, but it has to have a leading coefficient of 3. So basically, I'm going to multiply everything by 3, because the leading coefficient has to be a 3. So this is actually going to be 3x to the 4th minus 30x cubed plus 63x squared plus 120x minus 300. And again, something I do want to point out, that this is, the graph that I'm showing here is a generic graph. It may not, like if you plug that into the calculator and like, wait a minute, the graph doesn't match that. Well, I'm focusing on the zeros and the, and so this literally could come way down here and actually graph it, or this could come way up here and graph it. But in general, the graph is going to look like that. So something I want to point out. Now, by the way, this is the first part of 3.2. So make sure you click on the second part of this video as well.